Good morning, everyone. Hope you're fine today. And today's lesson is going to be online because of the situation. We know all of us know about Corona. So hope everyone will be safe and keep yourself safe anyway. Today's lesson is going to be about alternating sinusoidal current. So sinusoidal current. We're going to begin in this chapter. It is alternating. It means that it is changing. So the current is changing. And sinusoidal, it is going up and down. It is like sine and cosine functions. So actually, we're going to begin with a parallel plate. So we have here a parallel plate such that this parallel plate, it has two armatures, and these armatures, we're going to call them Q of A and Q of B. And in these Q of A and Q of B, there is a capacitor, and this capacitor has a voltage of UAB, which we're going to call the voltage of the capacitor. However, any capacitor has a capacitance. And what is a capacitance? A capacitance is actually C is equal Q over U of C. So the capacitance is actually the number of charges that is accumulated on the plates of this capacitor with respect to the voltage that is given to this capacitor. So that's the capacitance. It is expressed in farad. This is the charge expressed in coulombs, and the voltage expressed in volts. So a farad is coulomb per voltage. So that's the capacitance. However, if we want to know the charge Q of A, Q of A actually, it is what? Let's apply the equation. So the equation here, Q is equal CU of C. Q of A here, it is actually the capacitance, which is the number of charges accumulated per the unit voltage. CU of C. QA, this means that the current enters from here. If the current enters from here, so this means that it is UAB. So the current, we choose the current as the voltage. So if the current goes into A, this means that it is UAB. However, if it is QB, what is QB? It is C from here, if the current is going in this direction. So QB is equal to the capacitance times UBA. So what does this mean? UAB and UBA are two opposite voltages. So they are opposite to each other. So UAB is equal to minus UBA. This means that QA and QB are opposite. QA is equal to minus QB. That's the introduction of this chapter, which is very necessary to understand while we're going to study the charging and discharging phase. Okay? Now we're going to go forward. So we're going to continue what we have already begun with. And now we're going to see what is the capacitor's charge. The capacitor's charge is actually having two parallel plates. And these two parallel plates, they are connected with a resistance. And this resistance is connected to a LFG, or it is called actually a sinusoidal square signal. Sinusoidal square signal. This is C, this is U of C, and that's actually, we're going to use it to be A that's point M, and that's point B. We have a capacitance and a voltage of the capacitor is U of C, and we have a resistance, and U of R is the voltage of the resistance. However, the current is going in this direction of a square signal U of G. Of a square signal U of G. Actually, whenever we want to study this, we're going to study it like this is Q of A and Q of M. This is from point M, this is from point A. Okay? So we're going to study it first experimentally. So experimental study of an RC circuit. So that's the experimental study of an RC circuit. Well, we put the oscilloscope, we connect the oscilloscope such that we connect it here. I'm going to use another color, red. So we use this is the ground. So we want to measure two components, the capacitor and the resistance. For the capacitor and the resistance, we put the ground in between them. And we connect the first channel, Y1, to the resistance, such that a phase component ground. And then we want to connect to the capacitor, it is phase component ground. So the current is going in this direction, so UAM is positive because the current is entering in this direction as UAM. UMA is negative. UAM is positive because the current enters into A, into the phase. And the oscilloscope reads from the phase to the ground. However, when we continue here, the current enters from M to B. The current enters from M to B. This means that UMB is positive. Okay? But the oscilloscope reads the voltage from the phase to the ground. So UBM will be negative. So we use something in the oscilloscope inversion button so that it will be positive again. So let us study it experimentally, this signal. So we have, I'm going to draw a diagram. And dissect it into three different That's the first for the square signal. The second for the capacitor. And the third for the resistance. So this is in terms of time. And this is actually, we're going to call this is U of G, and that's U of the generator, and that's U of the capacitor, and that's U of the resistance. However, the voltage of the resistance is called the image of I. It's called the image of I. What do we mean by image of I? We mean by image of I that whenever I changes, U of R changes likewise. If I increases, U of I increases. If I decreases, U of R decreases. So they are directly proportional. And that's why we say U of R is the image of I. As if we are saying that U of R is a function of I. Is a function of I. Let's see what happens. We close the switch K, and the square signal, how does it function? So the square signal actually functions first when we close the switch. It was open and now we closed it. So it has taken a maximum value. Then it went to 0. It goes to 0. It is a discontinuous function. So it goes to 0. So this is half period. This is 0. This is 0. This is 0 level. It goes to 0 again. And now we have one period completed. And again, the square signal, the functioning of the square signal of this generator functions either maximum or 0. Maximum or 0. It doesn't function otherwise. Etc. and etc. So this is 3, t over 2, 1, 2, 3, etc. and etc. It goes to 2 periods and so forth. So half period, 1 period, 1.5 period, 2 periods, etc. and etc. So what happens when we open here the switch and then we close it? So the switch was opened and then we closed it. When we close the switch, the voltage will be maximum. When the voltage will be maximum, what happens in the circuit here? How much is the voltage UC? At T0 equals 0, there is no voltage here on the capacitor. So this means that we begin from 0. That's the first point. When the current arrives to this plate, at QA, plate QA, then it will start accumulating charges. So it will go bit by bit, up until it reaches a maximum at T over 2, period over 2. When at the same time, while this current is being overwhelmed with this circuit, what's happening with the resistance? At T0 equals 0, the resistance has a maximum voltage at the beginning. So we have, this is U of R maximum. So at T0 equals 0, U of C is 0. At T0 equals 0, U of R is maximum. At T0 equals 0. So when the current arrives to the plate of the capacitor will start to accumulate charges. As long as the capacitor will accumulate some charges, it won't allow the current to circulate in the circuit such that the U of R, the voltage of U of R, will start to decrease. So it will go this way. And then now the square signal goes to 0. When the square signal goes to 0, as if we opened the switch, we didn't open the switch, as if we opened the switch, what happens here? The voltage is now 0. The capacitor's voltage is now maximum. So whenever we have a maximum voltage for the capacitor tends to give out its voltage to the other side, so that the capacitor will give out its voltage and it will discharge going to one period. What happens with the current? We know that using the law of addition A of V, addition of voltages law, U of G is equal U of C, of course. U of C is UAM. Okay? So U of C is UAM. And here UAR, U of R is UBM, but inversion. Use the inversion. So U of C plus U of MB, or let us call it U of R as long as we have. So U of R. This means that U of R is Ri, right? And we can substitute it, so Ri is equal U of G minus U of C. So if we want to equate, so I is equal this over R. Divide by R so that we can find I. So this is U of G minus U of C over R. What happens to the current here? So whenever the voltage is maximum of the capacitor will give out its voltage. and its voltage will be transformed into the voltage of the resistance, okay, will be given out, so that when the capacitor's voltage is decreasing, the current will increase. Why? So I is UG minus UC. At this point, UG is 0. UG is 0 at this point. When the UG is 0, UC is maximum, and we'll see how the current will function. So UG is 0. So if this is 0, so I is minus U of C over R. So it will begin from the negative. So it begins from the negative and goes up. Okay, as the capacitor discharges within half a period, the resistance gains a voltage within half this period, and the issue goes on and on. Note that while the charging of the capacitor happens, the discharging of the resistance happens simultaneously at the same time. While the discharging of the capacitor happens, the charging of the resistance, or the accumulation or the consumption of the resistance will happen inside the resistance, and so forth. So that's actually an analysis for this one. So at T0 equals 0, here we have here UG. So we're gonna go here. This is U, C max. Okay, here at T equal T over 2. At T0 equals 0, UG max. From 0 to here, okay, as T increases from 0 to T period over 2, the U of G is actually maximum. And the U of C is increasing. So U of C increases from 0 to period over 2. However, U of R decreases from 0 to T over 2. While the capacitor has a maximum voltage at T over 2, the voltage of the generator is 0. And the capacitor will be discharging. While the capacitor is discharging, at the same time, it is giving out its electrons to the resistance. So that is, but from the negative side. So the current will increase and will consume actually the current, and this is happening actually simultaneously with this curve. And likewise, while the voltage is maximum, the capacitor is charging, the current in the resistance is decreasing, and so forth. What is worth mentioning here? Whenever we have the maximum voltage here, whenever we have the maximum voltage here, what is the current here? 0. The current here is 0. What does it mean physically? It means physically that whenever the capacitor is fully charged, no current will pass to the circuit anymore. Okay? I'm going to repeat the idea. Whenever the voltage of the capacitor is maximum, the capacitor stops the current from passing into the circuit. That's what it means. So I have UC maximum, I 0, and U of R is 0, because U of R is the image of I, and so forth. It goes charging the capacitor until the current is 0 and the voltage is 0. Again, when it discharges the capacitor, the I will increase, absolute value, of course. We're talking about absolute value here, and so forth. This is the experimental study actually that we are using here. UC here is decreasing, here UC max. So that's why here UC is decreasing from T over 2 till T. The current here absolutely here is decreasing, okay? Is decreasing because we have taken the absolute value of minus I, the absolute value is decreasing as if it is positive, but it's decreasing because it is consuming the current, and it goes on and on. That's the first part actually of the analysis of the RC circuit. Enjoy physics.